Okay, so in today's lesson we are going to start off talking about the right angles congruence theorem, and it's pretty much exactly what it sounds like. So the right angles congruence theorem just says that all right angles are congruent, so that's pretty easy to remember. So we have this example proof here. We have the given that angle 1 and angle 2 are right angles, and we need to prove that angle 1 is congruent to angle 2. So we know that the first step is going to be the given. Again, the given there was angle 1 and angle 2 are right angles. We know the last step is going to be angle 1 is congruent to angle 2, so that's what we're working towards. Now that we have the given in there, so again, we know that right angles are 90 degrees, and that's by definition a right angle is 90 degrees. So what we can write in for the next step is measure of angle 1 equals 90 degrees and measure of angle 2 equals 90 degrees because they're both right angles. And all you have to write for that is just definition of right angle. So that's nice and straightforward. Okay, then for step 3, we have measure of angle 1 equals measure of angle 2. We've just proven that they are both 90 degrees, so we know measure of angle 1 equals measure of angle 2. That would be the transitive property of equality. And then our last step, we have angle 1 is congruent to angle 2. So we could have that step written in right from the beginning, because we know that's what we're trying to prove. And that is just definition of congruent angles. We know they're both 90 degrees, so by definition, congruent angles, both 90 degrees. Okay, so let's go ahead and do example 1 here. This one will do a good job of showing how many steps you can save using the right angles congruence theorem. So we're writing a proof again here. We have our given line segment AB is perpendicular to line segment BC, and line segment DC is perpendicular to line segment BC. We have our illustration, and then we need to prove that angle B is congruent to angle C. Okay, so this one's going to save us a lot of steps. We're just going to have 3 steps here. So we have our given, the nice easy one. So again, we go ahead and put in our given. Line segment AB is perpendicular to line segment BC. Line segment DC is perpendicular to line segment BC. Then, for step 2, we know that angle B and angle C are right angles, and the reason that we know that is just by the definition of perpendicular lines, that you have these 2 line segments and they're going to form perpendicular lines there. So all you have to do is write definition of perpendicular lines, and once we know that angle B and angle C are right angles, we also know that angle B is congruent to angle C by the right angles congruence theorem. So you can see by using that theorem, it ended up saving a lot of steps for us here. Okay, so we're going to talk about a couple new theorems here. First we have theorem 2.4. Again, you don't need to know the number, but you do need to know the name. The name of theorem 2.4 is the congruent supplements theorem. And again, this one makes sense as long as you know your vocabulary words. So congruent, we know that they're going to be the same measurements here. The supplements, that's supplementary angle is what that's referring to. So whenever we have supplementary angles, that means that they total up to 180 degrees. So that makes this one pretty straightforward. So what this one's saying, if 2 angles are supplementary, or again, if they add up to 180 degrees, to the same angle, or to congruent angles, then they are congruent. So looking at the diagram here on the top, if angle 1 and angle 2 are supplementary, and angle 3 and angle 2 are supplementary, then angle 1 is congruent to angle 3. Makes sense. Okay, theorem 2.5 is very similar to that one. This is the congruent complements theorem, which, if you remember, complementary angles are going to total up to 90 degrees. And this one goes pretty much exactly as you'd expect if you understood the congruent supplements theorem. So we have if two angles are complementary to the same angle, complementary again, adding up to 90 degrees, or two congruent angles, then they are congruent. So in this diagram on the bottom here, if angle 4 and angle 5 are complementary and angle 6 and angle 5 are complementary, then we know that angle 4 is congruent to angle 6. Okay, so let's go ahead and do example 2 here. So with this one, we're given that angle 1 and angle 2 are supplements and angle 3 and angle 2 are supplements. And we need to prove that angle 1 is congruent to angle 3. So again, whenever you're setting it up, you want to go ahead and put your given first. So angle 1 and angle 2 are supplements, angle 3 and angle 2 are supplements. So we put those in for the given, and the thing that we're going to prove, that's going to end up being our last step, that angle 1 is congruent to angle 3. So we need to fill in the steps in the middle here. So again, we have our given in here, and that's that our sets of angles are supplements. So we can go back in with the next step here and say that if angle 1 plus angle 2 equals 180 degrees, and angle 3 and angle 2 added together equals 180 degrees, and again, that's just by definition of supplementary angles, so that one's nice and straightforward. Okay, so we've proven that those are both 180 degrees, those two sets of angles. So with the next step, we can come back in with the transitive property of equality and say that measure of angle 1 plus measure of angle 2 equals measure of angle 3 plus measure of angle 2. From there, you're subtracting measure of angle 2 from each side. That gives you the measure of angle 1 equals the measure of angle 3. So again, that's just subtraction. So subtraction property of equality. And if the measure of angle 1 equals the measure of angle 3, then that means that angle 1 is congruent to angle 3. And that's once again by definition of congruent angles this time. Okay, so now we have a postulate for you to learn. This is the linear pair postulate. This one pretty straightforward again. So if two angles form a linear pair, which we should know the definition of by now, then they are supplementary. And you can see in the illustration here we have angle 1 and angle 2 are forming a linear pair. So we know that the angles 1 and 2 are supplementary. And then for our theorem here, we have theorem 2.6, which is the vertical angles congruence theorem. That just means that vertical angles are congruent, which we know by definition at this point. So you're going to see a lot of situations like the bottom illustration here, the one for theorem 2.6, where you have the two intersecting lines and they form a couple sets of vertical pairs, the angle 1 and angle 3 and angle 2 and angle 4. And then, of course, you have your linear pairs there too, angle 1 and angle 2, angle 1 and angle 4, angle 2 and angle 3, angle 3 and angle 4. I think I got all of them there. Okay, so we have another proof that we're going to do here. So this is example 3. We are going to prove the vertical angles congruence theorem. We have our given here. Our angle 5 and angle 7 are vertical angles, and we need to prove that angle 5 is congruent to angle 7. So once again, our first step is going to be our given. Our last step is going to be what we're proving. So again, for step number 1 here, we have angle 5 and angle 7 are vertical angles, which is the given. Then the next part here, we have angle 5 and angle 6 are a linear pair. And we can also see that angle 6 and angle 7 are a linear pair. And this is that scenario that I just spoke of where you're going to see the two intersecting lines, and you'll you'll end up seeing this a lot this year. So this is definitely one of the main ones you want to know. So we have our two sets of linear pairs here, and so just by definition of linear pair, and then our next step for number 3, we have angle 5 and angle 6 are supplementary, and angle 6 and angle 7 are supplementary, and that's what we just learned, the linear pair postulate. And then for step 4, that's our prove. Angle 5 is congruent to angle 7, and that is the, actually they're calling this the congruent supplements theorem. That should actually be the congruent angles theorem. So again, congruent angles theorem should be in there. Let me try writing over this here. Okay. Okay, beautiful. Much better. Okay, and last thing that we have in this lesson is we have a standardized test practice problem here. We're going to use our illustration here, and we're going to find which equation can be used to find x. So, if you look at this here, we have a linear pair. And we have the angle that's 32 degrees. We have the angle that is 3x plus 1. Since they are a linear pair, we need that to equal to 180 degrees. So we'd just be adding those two angles together. So it'd be 32 plus 3x plus 1 is equal to, and be careful, 180 degrees. Don't get fooled by the first one. I'm giving you 90 degrees. And just because we can, let's go back in here and let's go ahead and solve our problem here. We have our 32 plus 3x plus 1. Sorry, this isn't pretty. At the moment, I'm having to use my finger here. I'm quite looking forward to the iPad Pro coming out, so I can use a nice stylus to make this do much better. Okay, so now that we have this down, okay, so we need to go ahead and subtract our 32 from both sides here. So that's going to give us our 3x plus 1. Subtract our 32 over on the right-hand side here. So that's going to give us 148. And then we can just subtract our 1, and that's going to give us 147. And yes, we actually get my favorite number here. No, I did not write this book. Okay, so our x is going to be 49.